Good evening, YouTubers. I saw this video and I really like it. How he approached solving this these circuits. And one thing that I have to say, I will use kind of a different approach, just so that you can expand the concept a little bit further. Again, still using the Kirchhoff rules, or Kirchhoff law about circuit. With that said, let me work on it. Hold for 1 second here until I do a change. All right. So let me put together the circuit here. Just to want to be sure that I put this right. So we have that. We have a battery, a resistor, another battery, and what is common between both is that there. Let me put this bigger. So now this is 4 ohms, and this is about 20 volts. This is 2 ohms, and this is a 10 volts battery. And so let's keep going. We have another resistor here. We have another battery here, and that's it. And this battery is 30, and this is 5 ohms. All right, and that's it. All right, so let's apply Kirchhoff law here. And one of the things that you quickly will learn is this is 20 volt and this is 10 volt, and they are kind of heading each other. So one of them will dominate. Definitely the 20 volt will dominate the 10. But just for entertaining let me do it. So let me do it differently. For example, let's say that for the sake of the argument, this current goes like this, and I call this one current 1. And looking this way, I mean, the only battery is only this one. So just for the again, for the sake of the argument, let's go that way as well. So this is current 2. You see? So we established the direction of those two currents. Let's now work on circuit number 1. On circuit, whoops, this looks very ugly. Let me fix this for you guys. So in circuit number 1, we have, if we apply Kirchhoff law, minus 10 plus E1 times 2 plus 20. Now we keep going, plus, and here is the question: how I treat this resistor that is in between, and now we check the direction of the current flow is coming down, and this one is coming down. Both are coming down. So very simple. You just add them. I1 plus I2 times 4 equals 0. So you complete the circuit number 1. Let's work on the circuit number 2, and we do the same. We start with the battery. That's minus 30 plus I2 times 5, or 5 times I2. This looks more elegant. So it's going to be 5, sorry for that, 5 times I2. And now we get here, so we said, well, it's the same as the other. So it's going to be I1 plus I2, because they are both going in the same direction, times 4 equal 0. That will be in the end of it. So I got the two circuit there, the two balance or Kirchhoff apply rules, and now we simplify. Like for example, first equation, we got a minus 10, a plus 20, that would be a plus 10, and then we got a 2I1 plus 4I1 plus 4I2, and that's equal 0. We keep simplifying. That's 2 and 4, that's 6. 10 plus 6I1 plus 4I2 equals 0. And now that's the end of the simplification. This is for equation number 1. Now for equation number 2, let's work it out the numbers. So that would be minus 30, still there's nothing else, plus 5e2 plus 4i1 times 4i2 equals 0. And now let's simplify a little bit. Minus 30, 5 and 4, that's 9, plus 4i1 equals 0. So that's the simplification for circuit number 2. Now let's arrange this a little bit different. So that would be 6a1, so 6 times i1 plus 4i2 equal minus 10. And the last one, that would be simple, minus sorry for that, it's 4, let me accommodate this way, 4i1 plus 9e2 equal 30, go the other way, equal 30. That's it. Now we only need to resolve for I1 and I2, and I can definitely solve this, you know, by substitution. But let's use Cramers rule. Let's apply another rule, Cramers rule. For example, I1. If I want the solution of I1 is as simple as saying, let's substitute this in the first column of my system, and it looks like this. I'm going to be using matrix, basically. It's going to be looks like this. Minus 10, 30, 4, and 9 divided by the determinant. And these are basically the determinant that I need to calculate here. And that will be 6, 4, and 4, and 9. So let's put a D here, and let's put a D here. That's the determinant of this and the determinant of that. So let's calculate the determinant of the numerator. That will be minus this times this, that will be minus 90 minus 30 by 4, 40, that's 120, divided by this determinant of the bottom. So that will be 54 minus 16, and that gives you a number. And that number is obviously, let's see, we can pull the calculator in a second, but let's work the other one, I2. Let's see what is I2. I2 is the same story. I mean, the nice thing is that you already got the denominator of the determinant. Let's work this. So it will be the determinant of the first part, which is basically 6, 4, minus 10 and 30, divided by the determinant of 6, 4, 4, 9, and that will be then 60, 180 minus 10, that's 40, over 54 minus 16. I can certainly do, let's see, so we got, let's pull the calculator here, just so that makes life easier, and we get that. So let's see. So I want to do the whole division, and it's taking me longer pulling the calculator than actually solving the problem. So here we are. So we got minus 90 and 120. That's 210 negative. Whoops. Little problem here with my electronic pen. Minus 210, and that's divided. I think that would be 38. Yeah, 38, and that will be 5.53 negative. That negative is very important, so we don't want to mess with it. So it's negative 5.53. How about this one? That's minus minus as a positive. So we got there is basically 220 positive divided by 38. That's 5.79. That's it. So now we got the current. Now the only argument that you have to be careful is that E1 is just negative. What that really means? It means this. Let's copy this for a second. Whoops. If I can copy it a little bit sometime. I'm copying that. So I have it here. And the only thing that you have to be careful is that I1, the current direction, 5.53, is not this way. The actual direction means that it's this way. That's all. So you put it right. This 5.53 is when I put this direction was clockwise, but actually the 553 is counterclockwise, okay, which is the correct answer. See, no big deal on that one. And this one is okay. That's precisely the direction that the current goes. So this is perfect. This is the way it should be, 579. Now the question is, what is the current going through here? But then this is going up. You complete this. This is going up, and this is coming down. So what's going up? 553 is going up. So E1 is 5.53, and I2 is coming down in the same direction. I2, I said that was I2 was 579. So which dominate? Obviously I2 will dominate, and the net current going through the resistor 4 is going down. If I want to write that down as a different current, like I3, that will be the difference between those. So that would be 579 less than 5. These numbers look so ugly. 5. I think that was 553. Here we go. I3 minus 579 minus 5.53. That's 0.26. That's it. End of the story. All right. Circuit can get very complicated. I mean, just stick to your rules. I mean, the direction, and don't worry about the results. The result just will let you know whether if you have the direction, correct from your intuition, your original intuition, or if need to be kind of a change a little bit. And that's all. That's what I put it this way, just so that you can see that the result was not in that direction. And obviously it is clear that it cannot be in this original direction. That had to be the other way, because this 20 will dominate this battery, and so forth. Anyway, that's basically it. I hope that you learn a different way to do the same problem. Thank you for your attention. Bye.